You've read the rules, you've created your strategies, you've put in the time, you've done the math. Now it's time to show us what you've got. Welcome to this week's episode of FMA Plus.
For those of you joining us for the first time, FMA Plus is a weekly web show hosted by First Mid-Atlantic. We're showcasing teams and stories from around the region. So, of course, our season is very much in question right now in 2020, but a bunch of mentors got together, we volunteered, we want to make sure that we spend the time to make every single team in our region be able to shine this season. Reporting in this week, we've got Team 193, Morte Beta from Flanders, New Jersey, Team 2180, Zero Gravity from Hamilton, New Jersey, Team 2590, Nemesis from Robbinsville, New Jersey, a rookie, Team 8139 from Egg Harbor City, New Jersey, and Team 1807, Redbird Robotics from Allentown, New Jersey. A very New Jersey set of teams today, but with our first episode, that's who we've got applying and who we have in. So make sure you apply for FMA Plus 2 to get your team on the show. Let's find out a little bit more about our teams this week.
As many of you know, the process involves applying to be featured in the lineup of an episode for FMA Plus. This week's lineup is comprised of teams that were very enthusiastic and very timely about submitting their applications. First up on the list, we have Team 193, Morte Beta. So we're going to go to that section now and learn a little bit more about what they do to just keep swimming. So me and Libby are here with Team 193 student representatives Anish, Sophia, Rohan, and Serena, and their mentor extraordinaire, Jessica Dennis. Sophia, why don't you take it away and tell us a little bit more about 193?
So we are one of two teams from Mount Olive High School, and we are the first JV FRC team in the world of first. We call ourselves a JV team, but we actually play the exact same game as everyone else, and all that JV really means is that we're all freshmen. And this is Beta's 8th season, but every single year it's a new group of people that's on the team because new freshman teams come in and groups of people come in. So none of us have ever really built a robot before. Morte Beta was created in 2013 to give a more hands-on opportunity to freshman FRC students because in our school of our size, there are a lot of people going on for the robotics team. And so underclassmen don't really get as much of an opportunity to work on the robot that upperclassmen really do.
That's really cool. So Morte Beta, obviously being the sister team, the JV team to Morte, Mount Olive Robotics team, Team 11, who I'm sure we'll hear from later in the FMA Plus season. But you guys applied first. Props to Beta. I'd love to hear a little bit about that relationship with Morte.
So we share a school with Morte 11, and we share our resources, our experience, and memories throughout the season. We definitely lack a lot of experience compared to them, but we make it up in our drive and our creativity, and we definitely have a sibling rivalry. It's a lot like gracious professionalism within First. We really want them to succeed, and we want to help them, and they want to help us, but we definitely compete as hard as possible, and we definitely want to beat them just like any other team, but I think it's a little bit more competitive between us.
Yeah, that's awesome. That was definitely one of the questions that I had on my list was, do you guys kind of kowtow to the upperclassmen, or are you guys the scrappy underclassmen that are getting in there to show them that, maybe experience isn't everything, I like that attitude and that approach.
Yeah, our enthusiasm is definitely really high, and so we definitely want to try as hard as we can to kind of do as well as them, if not better.
That's awesome. So Serena, it says here that you're the person to talk to about preparing for the build season and for the build season in general. Would you want to maybe speak a little bit about that?
Yeah, so being on beta gives us the opportunity to work hands-on with the robot, which we really wouldn't get on any other team. And we're a pretty small and unexperienced team, so we focus on more of the technical side at first. We have 3 sub-teams that each focus on a different aspect of the robot: electrical, programming, and mechanical. We all barely had any prior knowledge coming into this. Our mentors needed to teach us about First and the technical skills to design and build the robot. We learned most of the basics during Morte University, something we included in our preseason. We started to branch off on our own after absorbing what our mentors taught us. We gained confidence as the season went, and our robot came together quickly.
Serena, tell me a little bit about your build season process.
Right, so after the game came out, we spent the first week discussing the game and getting really familiar with it. We talked about different ways to get points, the field elements, and what we were really excited about for our robot. This basically led us to our game strategy. We agreed by majority on a robot that could shoot and climb. We wanted a robot to shoot from behind the control panel, so we would have a shorter cycle time for getting power cells, and so we wouldn't get in the way if any other robots wanted to shoot from closer to the port. We also wanted a robot that had 2 climbers so we could start at the middle of the generator switch. We knew we wanted to have a robot that could climb, so we thought we could make it as efficient as possible to maximize space, which would allow other robots on our alliance to climb as well. We designed the robot with trial and error, since none of us had experience in CAD. We first made wood prototypes and then moved on to metal.
So do you guys do any design layout at all? Maybe just conceptual sketches, hand sketches, things like that?
We did draw stuff with pencil and paper. Some of the mentors did CAD. I did some CAD personally, but that's like only to figure out positioning of a certain thing.
Cool. So Rohan, it looks like you're the guy to talk to about the drivetrain and the drive base specifically. Maybe you'd like to talk a little bit about that now.
Yep, for the drivetrain, it is the good old reliable AndyMark 14U4 chassis, and that's because we do not have to redesign a drivetrain, and this was the best option for us to choose. It has 6-inch pneumatic wheels for getting over the rendezvous point in this year's game. It was slightly modified to hold our gearboxes, and is powered by 4 Falcons, 2 on each side. It is a single-speed gearbox with a gear ratio of 75-13. And a planned change for this was to go from a double thickness pulley to a single pulley because they were shattering.
So moving on through the robot subsystems, let's talk a little bit about sort of your power cell pickup, that intake.
So our intake was the first design that we ever made, and it worked well, so we just had to improve on it. And it's a over-the-bumper design with a foam roller, and we have a PVC pipe and pipe insulation, which is covered in gaff tape, which prevents the foam from ripping. And it's powered by a Neo 550 motor, which is attached to a versaplanetary gearbox. And it uses pneumatic cylinders to pull the intake within the frame perimeter. And a tricky part of this was figuring out the best location for all our rigid pneumatics. And we also had to make sure that the intake had enough slack to move around, but not too much slack because it may become caught on other robots in a match. And another problem we had was jamming and ejection of power cells. So our intake ramp and compression were changed many times. So after that, when power cells are brought in, they would also get caught on the sides of our ramp. And to avoid this, we added some surgical tubing. We tied it to the tower and intake bars to bounce any ejected power cells inward.
And that's actually something we're looking at on your video here. Is we can actually see in Morte Beta's prototype videos, their intake power cell goes up, looks great, and then it's a little squishy. So I know this was one of the biggest problems with the power cells this year, was just how easily they like to jam in traditional FRC mechanisms. So it's good to hear you guys were iterating on making sure they got unstuck.
Yeah, I know. I think what really surprised me this year was just how small of a gap a power cell could work its way into. Like 1 inch, 3/4 of an inch. It's crushing down into a little yellow pancake of disappointment. Rohan, let's talk now about your tower and your feeder system.
So the tower is the main structure of the robot, and it is made out of VersaFrame. It brings the power cells to the shooter as it holds 3 of them. It has 2 belts on pulleys, which are on one side, along with compliance wheels to push the power cells into our shooter. And this system is powered by 2 Neo 550 motors, which are connected to versaplanetary gearboxes, which work with clamping gearboxes and bearing blocks. If there were any areas that we would have been able to pay more attention to, it would have been the tower, because it had frequent power cell jams, and it would impact how the power cells would be fed into the shooter. And a planned improvement for the tower was to attach a second system of belts so the power cells would not jam as often.
That's great. I love that you guys are thinking ahead to, when we eventually get back to our robots and what we can do with them is what the iterations that you guys would implement. That is a sign of a really good engineering process. So I think you have a lot to be proud of. So Anish, you are here to talk about the shooter of this robot. Let's see how the power cells get into that power port. Let's talk about your power cell shooter.
For a shooter, we put a large focus on the consistency and accuracy. So we also began by making different prototypes out of wood. We had a double flywheel and a single flywheel. We also accounted for human error while we were testing these two prototypes, such as the placement of the power cell into the shooter and also the velocity of the power cell while entering. In our wooden prototypes, we really looked at the angles, compression, wheel thread, the number of wheels, and the wheel mass and size. Also for the single flywheel, we experimented with a curved versus a straight hood. We settled on a curved hood for consistent compression. The wheels are a really important part for our shooter because heavier wheels would mean more stored energy, which would give us a good consistency and shot, but a long time to reach its full speed since it's really heavy. Both prototypes had their advantages and disadvantages and were fairly even on performance scale.
Yeah, I can
So
see in your video here is you've got the two sort of shooter types going head to head. It looks like in your testing. So that's a really nice way of quite literally comparing one to one what you're going to be doing. So nice work. What was next for that shooter?
our final metalwork that we decided was a single flywheel as opposed to the dual flywheel. Some flaws of the double flywheel that we saw is that it added a lot of complexity to our robot, and it also had a significant more amount of power to the power cell, which was unnecessary because it would bounce out of the power port instead of going inside. In our final design, we had a single flywheel with 4 high grip wheels. It was mounted to the tower on top of an Armorbot turret. We had 2 Neo motors at velocity control geared to reach higher speeds. We also had an adjustable curved hood made of corrugated plastic, and it was powered by a 25 kg servo and an overdrive ratio with a belt and pulleys. The limelight was used to track the power port and move the hood and turret accordingly. For our turret, it was powered with the Sen 75 Pro and encoder. Originally, we didn't plan to have a turret because it would add a lot of complexity to our robot, which wasn't that good, but it was definitely worth it because it added much more versatility to the shooter. And it was best seen at the practice field, and it was really amusing to see our robot shoot from various areas across the field. Programming was able to bring their skills to improve our shooter with the limelight that outputs an X and Y coordinate of the target position. Programming also made mathematical relationships to automatically adjust the hood and turret positions.
Awesome. So it sounds like you guys are super prepared to score power cells into the power port. And obviously, you know how you're getting them off the floor, or I guess acquiring the power cells. But now let's talk endgame. Sophia, what kind of climber situation does Morte Beta have planned for the endgame this year?
So we knew that climber was a really important thing that we wanted, but it ended up starting a lot later in the build season compared to, say, the shooter, because that took a lot of prototyping in the early build season. We had initially made a metal prototype that was using this really big piston and a pneumatic system. But when we were testing, we found that the pneumatic system that would be required for this single piston to carry the entire weight of the robot would need 6 tanks. So it'd be really big, and we didn't want to spend that much room on our robot for the pneumatics tank. We had little room for error, and we'd only really have one chance to climb with that system. And since we have an all freshman team, we don't have that experience of a drive team, so we didn't want to take that chance. So we decided to draw up a new idea that used a spring, PVC, cord, strap, and a motor system all within a 2x1 channel. Even that prototype that we had made got changed a lot, and we used a lot of trial and error to find different ways to prevent jams and maximize the climber's reach. Eventually, we had settled on a design that had a PVC running through this fabric sleeve that was attached to a 1x1 that had a constant force spring that was running along the side of the 1x1 inside the fabric sleeve to propel the PVC upward towards the generator switch. This design really prevented a lot of jams, and it also stopped the climber from leaning while it was going upward, because we used a very sturdy fabric that would hold it up. We also added a ratcheting attachment to the gearbox so the robot would not fall when the power was cut to it. And we were planning on adding limit switches at the bottom so we did not damage the motor during the game. And since we didn't use a lot of CAD beforehand, and most of it was used for the shooter and tower placement, we had a lot of trouble finding where to mount the climber, especially because we wanted the robot to be stable and we didn't want to swing a lot, because that'd be very dangerous on the field for our robot and everyone else's robots. So we mounted 2 climbers, one on each side, over top of the drivetrain wheels, so that the weight was centrally balanced.
There's not a good way to sort of plan for that. I think this is a really, really smart way of integrating a system that you didn't originally plan to have in a certain spot. That's really cool, guys. I want to talk about I've obviously been in First Mid-Atlantic for 15 years. I've seen Morte evolve. I've also seen Morte Beta from the beginning. One of my favorite things about Morte Beta is that Morte Beta has the best spirit and imagery that, like, of all time. Obviously, with First Rise, sponsored by Star Wars Force for Change this year, we have a whole lot of imagery to work with, and I really want to dive into what Morte Beta did with all of this amazing beta spirit and imagery with the Star Wars theme. We got to talk about Beta Yoda. So Serena, maybe cue us in on that.
Yeah, so Spirit, as you already said, it's a big part of beta tradition, and we had so much fun coming up with the story behind Beta Yoda this year. Our mentors are Mortalorians, while we consider ourselves the Beta Wands. Like how Padawans are the Jedis in training in Star Wars, we are learning from our mentors. And our motto is just keep swimming. And our mascot is usually a beta fish, but this year we decided to get creative and make it Beta Yoda. As Mortalorians, our mentors teach us what they know, and we take what they teach us, grow, and pass our learning on.
I'm obsessed with Beta Yoda.
I also see in here you guys have a graphic, and it shows the Beta Yoda inside of a BB-8 inspired fishbowl with the very compelling words at the top that says "Swim or swim not, there is no sink," which is incredible. I love that.
Morte Beta, we have had an absolutely amazing time talking to you today. Is there any other story you want to share, or any other information that you want to give to the First Mid-Atlantic world and those watching online?
We definitely want to give a huge thanks to our mentors, all the students on our team, our parents, the Mount Olive Board of Education, Siemens, and all of our other sponsors for making this season possible and really amazing for us.
And you can also go to morte11.org to find out more about Morte as a whole community.
What an awesome shout out to the rest of your First family. I love that. So, of course, bringing us awesome spirit, awesome robots, and fantastic stories to tell. This has been our time with 193 Morte Beta. Thank you guys so mu+, for joining us today on FMA Plus, and we will catch you soon. Take care.
That was awesome. I'm a huge fan of Beta Yoda.
Up next is Team 2180, Zero Gravity from Hamilton, New Jersey. They wrote in and specifically wanted to share not only about their robot and having competed in an out-of-district event in the Chesapeake District, but also that they really overhauled their engineering process and that it made a huge benefit to them as a team. So let's learn a little bit more about 2180's design process and the robot they made with it. All right, to kick off our episode with Team 2180, we've got Billy and Ravi here. So Billy, why don't you tell me a little bit about your team?
Hi, I am Billy from Team 2180. We are from Hamilton, New Jersey, out of Steinert High School. And this is Ravi.
And I'm Ravi, also 2180. I do the programming and Billy does pretty much everything else.
Awesome.
Cool. So Billy or Ravi, maybe one of you can tell us about your process. In our notes here, it says you guys want to talk a little bit about your goals and the complications you guys ran into in the previous seasons.
So mainly last year and a little bit the year before that, we ran into a bunch of problems at competitions, involving our pit crew having to fix the robot after every match because of a more of an incomplete design, and a design that really didn't hold up well for the battering we took at our competitions. And we felt that one of the main problems with our design process of previous years was that once we found a design, we really stuck with it, and we didn't really iterate or prototype it at all. And we found no things that could go wrong with it that we could fix before we got to the competition field. And one of the other things that was a large problem for our team in previous years was inconsistent mechanical fabrication, because the only real way we had of fabricating most of our 2x1 aluminum was through a mill that is probably pre-World War II.
Nice.
That's kind
You
of
guys are
cool.
working. You guys are working on some antique equipment there. That's awesome.
Yes.
So, what did you guys go into specifically for this new season? If you said you're we're gonna overhaul our process, make sure our designs are effective. How'd you do that?
So and I should say in previous years, we really had one or two kids kind of design most of our robot in our CAD and our SolidWorks. And this year we got a bunch of new freshmen, and I think 3 or 4 freshmen pretty much designed our whole robot, which was really impressive. They had great help from all of our mentors, but that was something that really helped us this year, because they came in with an untainted eye of stuff that our team personally had our team personally didn't like, but they had never seen it before, so they didn't know what to think about it.
And then also we put a lot of effort into really getting it, right, through testing, through prototyping, and then fixing as many little issues as we could find before getting to final production, before hitting the final robot, which is really something that, at least from my sort of distant perspective as a programming captain, something that we haven't really done in previous years.
Cool. So let me ask you guys this. I see a little note here. This might be a silly question, but it says here you started with a black box. What does that mean?
So every year, as soon as we get home from kickoff, we all pile into our room, and we go over the entire game, what everything's worth, all the point values. We read through the manual, and then we all sit together as a team and we think about what we want the robot to do, but we don't imagine any of what it's going to actually look like. So we just envision a floating black box. I shouldn't say floating, because that it is moving in some unknown way and accomplishing all of these game tasks in some unknown way.
So you guys talk about a priority list in terms of how you decide what the robot's going to do. What did your priority list look like this year? How'd that process go for you?
So once we finished our black box meeting, we had this huge priority list of things that we wanted to accomplish, and it involved everything on the field. And we knew that if we wanted to be able to accomplish all of our very high aspirations, we really needed to focus on designing subsystems and designing parts that would fit together, but that could be maintained, programmed, designed, and constructed separately.
It's always really important to look at things you can iterate forward on, and especially as you're cleaning up your build season and trying to make it a really documented, robust engineering process. There's a lot that goes into that. So what was your next step? Where did your robot end up?
So I think our subsystem that probably went through the most iteration would have to be our intake and our funnel, as we called it. As you can see, it's made out of Lexan and some PVC wrapped in rubber on the final robot. And our first prototype was wood with a couple of bearings punched into it. So I think it's really interesting to look at that and to see how far it came to find its final form. It was something that we especially struggled with at our competition. We had a lot of trouble with that particular subsystem getting jammed, or it would just not fire in specific matches. And that was something that our pit team and Ravi worked really hard on to get going while we were at the competition.
And then we later actually improved it, although, with how things turned out, that improvement isn't going to see competition. But the newest version actually fixed a lot of the issues that we were having. So we kept iterating through that.
Cool.
Yeah, I mean, looking through the pictures of sort of even your iterations of intake, everything looks really clean, and everything looks great and well put together. So as you guys got ready for competition, you said you wanted to prioritize doing a little bit of everything in the game. I know, Robbie, you talked about you're pretty proud of the robot's power cell shooter. So why don't you tell me a little bit about that?
Yeah. So certainly that the top of our priority list was being able to shoot. It was the main game piece after all, and we definitely achieved it. Initially we were sort of hoping to get a adjustable hood for shooting at a distance, but we wound up just going with something where we would slam a line directly into the target, and it worked really well. I'm partial to it just because I spent most of the build season working on the code that would keep it consistent, keep it accurate, and it actually wound up working pretty well once we got to competition code wise. But mechanically it was beautiful. Even the first prototype shot pretty well, and the actual final product was really incredible to work with.
Cool. All right, Ravi and Billy from 2180. Let me ask you guys, one thing that 2180 has on their belt right now is the fact that they got the opportunity to compete this year, which a lot of us have not yet been able to do. So what can you tell us about competing in Infinite Recharge in 2020 so far this year?
So for me, this year was a lot different because the last 2 years, I was our operator, but our main driver graduated last year, so I was bumped up and promoted. So that had a very different feel for me. That was a lot of fun. But I feel like the entire attitude around the game this year is a lot different. Like, teams really have to work together in order to score the most points. It's something that you kind of saw last year with assembling the rocket. You had to put on those hatch panels before you could put the cargo in. And it was something that I thought was really interesting this year with different team strategies of where they like to collect cargo, and how a lot of teams were just like, oh, you like to go there? We'll go across the field. It's fine. You can do that. We're good. We're flexible. So that was really interesting for me to see, kind of the evolution of everything that has kind of the evolution of the game this year.
Cool. Let me ask you this, guys. What was the overall success rate of going with that close wall shooter? I know that's a really interesting approach to the game. It's definitely one that I like. I like the simple elegance of it. How did that go? Do you think that was the right move for you guys?
I absolutely think that was the right move for us. That was incredibly accurate. It was super consistent. It always hit right off the roof. And sometimes we would even get a little bit of surprise, and maybe 2 or 3 would go in the back goal, and that's always extra points for us.
Cool.
But it was
Awesome.
really accurate, and something that I definitely would choose to do again if we could go back and restart the season.
So the last note on here about your competition experience I have to ask about is, it says you played a lot of defense in your first day of competition. What was that like?
So we went in with bare bones programming, and that's something that Robbie is very proud of, how he was able to get the entire robot running in the pit.
Not proud of going in without anything, but I am proud of how quickly we got it to something.
Good to be
Fair
proud
enough.
of. Yeah.
So playing defense was just an awesome experience for us. We were a tall robot, which I don't think a lot of teams are expecting a tall robot to try to play defense on them. In our first match, the same team shot 3 different power cells into us because I guess they thought we would leave, but we weren't going anywhere. We found that what worked best was parking in front of our trench run, or in front of the other team's trench run, and a lot of teams had their limelights pretty low, so we could just block their limelight with our robot, and they would not be able to shoot at all. Something you do have to watch out for, though, when playing defense in this game, and this is something I learned the hard way, is the tech fouls. because they are very lax with them. And that was something we got quite a few of because I floored it a little bit too much.
Sent it a little bit too hard. I mean,
Yeah.
the protected zones are an interesting component of strategy, but yeah, if you're playing defense, definitely something to watch out for. So, Ravi, you talked about that you were proud of getting everything together in the pit at competition. What were some of your other improvements at competition? You know, what did you guys not get to until you got to that Bethesda event, and how did you get through it?
Well, Billy and I both made the brilliant decision of going on a school trip to DC for the 3 days before the competition. And, you know, those last 6 hours are really programming's a special time to shine, which I wasn't there for. So when we actually got to competition, the robot drove, if somewhat inconsistently, and not a lot else. And match by match, we went through and we joked it was like unlocking new abilities in a video game, subsystem by subsystem, actually getting out there and being able to perform better and better until, you know, really the capstone on the first day, we finally got a really simple working auto done and got it tested on the field.
There you go. I mean, those at event and on-field improvements are so key. There are so many things that you don't know until you hit the real carpet, and I hope we all get the chance to experience that at some point this year, but I know you guys are very lucky to have had that. And thank you for sharing your competition experience with us, for those of us who have not gotten to do it yet. So 2180, Zero Gravity, we've loved having you on. Are there any other pieces about your team that you guys want to share with us on tonight's episode of FMA Plus?
So one of the things that our team really likes to focus on is our community outreach. And the Township of Hamilton, thankfully, has a lot of opportunities that we were able to go to, such as the Walk for Life and Boardwalk Night and the newly added Tech Night, which are all things that we can go to and we can show off our robot and our team to all the little kids and their parents. And another thing that we all love to do every year is host our own FLL competition, which we named Steinert Slam. So we have more and more teams every year come. It's a great experience for the kids in FLL to get to compete with their robots. I believe this year we had 3 or 4 teams qualify for the regional tournament of FLL. And it's a lot of fun for the whole team, for our whole team. Friday night, we all pack into the gym and set up everything, and we're out by 11. And then the next day, we all get there at 6, and we don't leave until like 7:30 or 8. And it's a tiring weekend, but it is a lot of fun.
Yeah, no, that stuff's the best. I think part of the being in the first family is making sure that we, help out our first LEGO League, our first Tech Challenge buddies as well. So 2180, thank you guys so much for being here. If I want to follow and I want to keep up on your team's progress, where can I find you guys?
So you can find us on our Twitter at FRC Team 2180 and on our Instagram, Zero Gravity 2180. Oh, and our website, which is zerogravity2180.com.
Cool. I can't think of a better way to end this awesome conversation. Thank you again, 2180, Billy, Ravi, and their mentor, Brandon. You guys were awesome. And we'll talk to you again soon.
Thanks for having us. It was great.
Thank you for having us.
Definitely an awesome insight to some time on the infinite recharge field. 2180, I liked your take on where to shoot from on the field, an up-close shot into the power port. So hopefully we'll be back on the field soon and can all see it in action. Jeff, let's meet our next team tonight.
All right, so next up, this team was prepared enough to have a presentation ready to go for the recording session with FMA Plus. We're going to do a deep dive into their robot, the processes they took to produce that robot, as well as the upgrades for the future of that robot. Let's hear from Team 2590, Nemesis.
We're here on FMA Plus with Team 2590, Nemesis, out of Robbinsville, New Jersey. They're here tonight to tell us about their robot, do a really deep dive into their subsystems. So we're here with Connie, Danny, and Macho, as well as mentors Peter, Josh, and Donna. So Nemesis, let's take it away. Let's hear about your robot.
Hello, I'm Danny, and I'm a co-CTO as well as a lead designer.
Hi, I'm Connie. I'm the co-CTO, project manager, and lead machinist.
Hi, I'm Macho, and I'm a lead designer.
This is our 2020 Infinite Recharge robot. named Hades. This is a CAD rendering that we made in Autodesk Inventor. And on the right is a picture of us on the field at the Northern Connecticut district event that we were fortunate enough to be able to attend. So at the beginning of the season, we made a priority list of things that we wanted our robot to do. So first, we wanted to shoot from anywhere, even while under defense. Second, we wanted to achieve the trench shot, which is the shot from the far side of the control panel. Third, we wanted to have post-climb leveling to enable a third robot to climb. And fourth, we possibly wanted to make a buddy climb so that when we climb, we lift another robot with us.
So when deciding what shooter to use, we were looking at a single flywheel hooded shooter or a dual flywheel hooded shooter. We tested both shooters by shooting from 35 feet, the trench shot. On the left is a video of our prototype hooded shooter. We found it to be more accurate and consistent than the double flywheel. On the right with the double flywheel, here it is. We're a little less consistent, so we decided to stick with the single flywheel hooded shooter.
This is our indexer prototype. It's just a way for us to go from our hopper to our conveyor. So on the left, those green wheels are our intake, the green wheels on our right are our indexer, and the white acrylic represents our conveyor. We had a lot of trouble going from the intake to the conveyor and realized we need something constantly moving and touching the ball. So we have wheels on both sides of our hopper, one side going faster than the other, and that just allows us to center one ball at a time and prevent jamming.
So on the next slide is our climber leveler prototype. This essentially works by having two wheels that rotate and pull us up or down the bar so that we can level. On this prototype, actually, we added a second robot's weight and batteries to the first robot that we have hanging because we were still testing with a buddy climb and lifting possibly another robot.
For the buddy climb, we were inspired by 148 from 2018, as you can see in the video on the left. So the idea is to stick Velcro tabs onto the other robot to pull them in, grab them, and lift them. On the right, you can see us actually getting the prototype to work, but unfortunately, by that time, it wasn't robot ready and we didn't have weight for it. So we decided to drop the buddy climb. For the drivetrain, we went with a West Coast Drive 27.5 by 32 inches squared with a speed of 8 feet per second. Driven by 4 Falcons, we used 8 6-inch pneumatic wheels with an 1/8-inch drop center. The benefit of the pneumatic wheels is that it allows our tall robot to get through the rendezvous zone quickly. The purpose of the 8 wheels is that it keeps our robot steady so that while we're shooting, it keeps a constant shooting angle. And for the trench shot, that makes a big difference on whether we score or not.
So on the next slide is our intake and hopper mechanism, which we actually combined because they both needed to extend outside of a robot. We use a pneumatically actuated linear slide system to slide both out around 8 inches so that we can hold the maximum amount of 5 balls. Our intake itself is comprised of a polycarb tube that we wrapped in grip tape that is just as grippy as compliant wheels, but weighs a little bit less.
For our final indexer, we went with 2 4-inch compliant wheels on either side of our hopper. Our conveyor is polycord bands on the front and back, and it's powered by a Neo 550 in the back. The blue wheel that you see is what we call our traffic cop. It's powered separately from our conveyor, so the bands on that shaft spin freely. This just allows us to control the flow of balls better and prevent further jamming.
So here we have our single flywheel shooter. We used a 6-inch Fairlane wheel. It has a variable position hood. This allows us to shoot from the initiation line all the way back to the far trench. And with constant limelight tracking, we were able to lock onto the power port using our turret to avoid defense.
So our Skywalker is the name of our climber leveler system. This mechanism uses 2 3-inch Coulsons powered by a 100-to-1 Neo 550 to allow us to roll over the bar to get the extra 15 points. That mechanism is on a cascading elevator that's powered by 1 Falcon 500 motor that, because of a custom gearbox, can lift the entire weight of our robot. Just to talk about software for a minute, we use a limelight to auto-align our turret. So wherever we are, our turret is facing the power port. And that limelight also has distance sensing so that our shooter hood can adjust so that no matter what distance we are away, we can still make the shots in. We use proximity sensors in our conveyor so that we feed a ball every 7 inches so that once we go to shoot, all 5 balls are right next to each other and we can shoot faster. In Auton, we use path following software so we can have paths such as one where we shoot 3 balls from the initiation line go into the trench, pick up 3 more, and then shoot those also.
This is a demonstration of our robot. We were just testing our intake to shoot our subsystems on the left. We were able to make multiple outer and inner port shots from the far trench. However, we noticed that when the balls were worn out or torn apart, they didn't shoot as far as we wanted them to. On the right, we have our turret. This is the first time that we got a gear machined. We sent it out to one of our sponsors who laser cut it out, and it's powered by a Neo 550 on a Versa with a pinion gear. So next we have our robot performing at our competition. It's hard to see, but we're in the left back by the Red Alliance trench, shooting a couple shots in teleop. On the right side, we were able to get a level triple climb with our partners in qualifications. We're climbing on the right. During this competition, we ended as the 8th Alliance captain and we're semifinalists. To top it all off, we also won the Entrepreneurship Award.
So after Connecticut, we saw a few things that we could change or redesign in our robot, most notably our indexer, because it was very prone to jamming because it overcompressed the balls. So our new design uses a turntable on the bottom to spin the balls in and a ramp that also removes all the dead zones. And then it still feeds our conveyor, just like the old one. Our Skywalker, during the competition, we had a few problems with because it was hard to line up both of the hooks and wheels on the bar. So sometimes when we would climb, only one wheel would get on, we wouldn't be able to level. We realized that we didn't need both wheels, so removed one. So now we can climb every single time and level once we're up there.
There were 2 main issues with our drivetrain. First was our turning radius is not as good as we planned it to be because of how the pneumatic wheels squish, leading to scrub since the drop center was apparently not enough. The other issue is our high center of gravity. It caused us to be extremely chippy, making it harder to maneuver and intake power cells. So in order to solve both of these issues without having to remachine the entire drivetrain, we made a simpler fix by changing just the wheel setup to 2 Omnis in the front and 4 pneumatic wheels in the back. This way we maintained our stable, powerful pushing force while also decreasing the turning radius. So this concludes our technical overview of the robot. I want to thank you all for listening to us. Before we move on, we would like to thank our generous sponsors for helping us and the FIRST community.
First off, question that I've always kind of had rolling around in my head ever since, seeing Nemesis for the first time. What I always appreciate is some of the really, really eloquent theming or maybe marketing aspects of your team. Where did Hades come from? What inspired you guys to name your robot after, if I'm not incorrect, the Greek god of the underworld? Is that correct?
Yeah. So back in 2013, we started a naming system where we name all of our robots starting from A after a Greek god or goddess, because Nemesis is the Greek goddess of, I think, revenge and rivalry, something like that. So A was Athena, then next year was Bellerothon, then Calypso, Daedalus, and then now we're on H, and it is Hades. We thought it was a fun sounding name.
I will say that I personally preferred Hephaestus a lot better because, it's the god of engineering, that's what we're all about, but I was outvoted.
We were outvoted, Macho.
Yeah, well, Hades is definitely the more intimidating, aggressive name, which has its own advantages for sure.
Yeah.
I like the attention to sort of the brand over time too. I think that's something that, with a FIRST community and a game and a season that changes obviously every year, right? We've got Destination Deep Space, Infinite Recharge, and those are kind of similar, but then you had, Stronghold and Steamworks. I think it's really cool to see sort of an element of a team brand that persists long term rather than just sort of like this year's robot is Baby Yoda, right? Which is also fun, and I love theme embracing, but I really like the idea of the attention to detail over the amount of time the team's been around. So very cool. Props.
Is there anything that you think, if you could rewind time and go back to when you were conceptualizing and designing your robot, if you knew what you knew now back then, that you would change, that would lead you to change your priority list or maybe change your design directive after playing this game for real?
So there was a time when we were thinking about shooting from the target zone, and then we realized we don't need this. There's no reason, because we can get a consistent shot in the initiation line and that cuts down cycle time. So we were thinking of target zone for a little while, but we didn't really need to work on that at all.
So let me ask you this then. Interesting design you guys have. What was the thought process behind committing to a tall robot versus a shorter robot that could, you know, allow movement underneath the control panel through the trench zone?
So for that decision, we kind of tried to see how the path would be different if we were to be a tall versus short. We found that it didn't. There was definitely a difference, but if we were a really good tall robot, and with a tall robot you have a lot less restrictions, you can fit balls a lot easier. We decided not to restrict ourselves size-wise for like maybe a 1 second improvement. That was kind of the decision behind that.
Cool. So you guys were able to, you considered it and you were able to quantify, using estimates, whether the risk was worth the reward, so to speak. That
Yeah,
makes
yeah. We
sense.
actually we made a spreadsheet at the beginning of the season, and we kind of guesstimated the time, and we looked at what would strategically be the best place to put our time into. It was actually really cool. It's something that I don't think we did it last year, but we did it this year, and it was really cool.
So any of you guys on the call, were you part of the drive team or of the pit crew, like competition teams?
I am the drive coach, yes, and both of them are pit crews. So
Awesome. So that's you, Danny. You said you're the drive coach?
I am the drive coach, yes.
All right. Let me ask you this, Danny. How much did you guys end up using the Skywalker mechanism? What's your opinion as a drive coach that's played Infinite Recharge in terms of the ability to level out a climb of more than one robot?
I would say, from what I saw, the I think it's 8 degrees is very generous. There's times where I thought we weren't going to get the points. I looked over and I'm like, well, we don't need a level because I can see on the screen the bar is level. I will say there's a few times where we did use it and we earned the extra 15 points. And there's a few times where we should have and we didn't because we just ran out of time as matches go. So I would say it's most definitely worth it. It was, I would say the mechanism itself is a little bit heavier than something that doesn't actuate, but not by much. And the extra added design time and weight, I would say is most definitely worth it. Even if it's only 3-4 matches, you get the extra 15 points. Those ranking points can start adding up if that's the difference.
Let me ask you guys this from a design perspective on the robot. Did you at all ever consider a control panel mechanism, a mechanism to spin the color wheel?
Okay, yeah. So to be honest, we kind of were not thinking about it for most of the season. And then we do have a way to attach the color wheel now, but due to weight, we weren't able to do it. And then we saw the week 0 events happen, and we realized that we might not need it just yet. And if we do need it, we'll make weight and then we'll put it back on. But
okay, cool. And you guys have what I liked about your presentation. Another thing I liked about it is you talk about upgrades or additions or modifications to your robot. Are those currently implemented on your robot, or are those like the next steps, like the future iterations of the robot coming up? Like, where are you guys at in that process?
So all of these changes are on the robot right now. I think there's one part that we needed to 3D print that on the indexer. That might be it. Besides that, everything is made. Since we might have more time now. I know that there's a new Skywalker that might be made. We'll see if we really need it.
Danny, you said you're the drive coach. What's the one piece of advice you'd give to other drive coaches who haven't played yet? As they prepare to go into, their first, debut event with Infinite Recharge as an experienced drive coach in this game now?
I would say generally just knowing what your team can do beforehand and talking with the other teams, that's always very helpful. That's for every game. But in the match, you have to be able to fight for what you can do and what is actually happening on the field. And being able to say in mid-match, maybe we need to adjust the strategy and someone needs to move out of our way, or we need to move out of someone else's way. That's very instrumental.
Cool. Well, Libby, that's all I got for these guys, for sure.
Yeah, and you asked so many insightful questions. I'm not sure I have much else to add. Nemesis, you did an awesome job sort of contributing with your robot design and your process and, you know, your experience having played Infinite Recharge. So Team 2590, Nemesis, thank you so much for being on FMA Plus tonight. If I want to learn more about your team, where can I find you?
So our website is frc2590.org, and you can find all our social media there, or all of our ads are at frc2590.
Awesome. Well, thank you so much for being on FMA Plus tonight. We appreciate your time. We appreciate your detailed presentation about your robot and your season. We hope we see you on the carpet again sometime this year. And let's go check in with some of our other teams tonight. Awesome job, 2590. It's really cool to hear from a team who's competed and then also thought through the iterations for future generations of the robot. So we have 2 more teams to feature tonight, but just like at every first event, in this digital season, we also need to hear from some of our sponsors. First Mid-Atlantic is grateful for the generous support of sponsors. We're incredibly fortunate to have one of our strategic sponsors, Stryker Corporation, provide this inspirational message from Robert Cohen. He's the VP of Global R&D and the Chief Technology Officer at Stryker Joint Replacement.
Hello, everyone, and welcome to episode 1 of the First Robotics new webcast. My name is Robert Cohen, and I'm the Vice President of Research and Development and Chief Technology Officer at Stryker Joint Replacement. I am also a mechanical engineer and a proud graduate of the New Jersey Institute of Technology in Newark, New Jersey. For those who don't know, Stryker is one of the world's leading medical technology companies, and we have 2 New Jersey offices in Mahwah and Allendale. With locations across the world, we are proud to create products and services that help patients get back to what matters. For some patients, that means getting their mobility back with a hip and knee joint replacement surgery. For others, it means receiving life-saving surgery. We take pride in helping patients in many ways with innovation that improves outcomes, using 3D printing, computer simulations, and new materials, and robotics in the operating room. My team is made up of talented engineers and scientists who've been volunteering as First Robotics mentors to Team 752, Science Park High School in Newark, New Jersey, and Team 6860, International High School in Paterson, New Jersey. Each day, Stryker employees come to work with one mission. We are driven to make healthcare better. We support First Robotics through donations and mentorship because we believe that STEM education and the valuable skills you are learning will allow you to create a more vibrant future for our local and global communities. Speaking of our global community, I was so honored to be asked to speak tonight, given all that is going on in the world right now. STEM skills are essential to developing life-saving solutions to healthcare challenges, such as the coronavirus. As you continue your STEM journey, maybe you want a career in healthcare and you get motivated to help serve patients struck by a global health crisis, to look at this as an opportunity to be part of developing the potential solution. We need more young men and women entering the healthcare field as scientists, software programmers, and engineers to develop innovations that address the needs of patients, first responders, and healthcare professionals all over the world. Your thoughts and your ideas to solving problems can make a difference. It's critical that healthcare companies like Stryker invest in STEM education so students like you can help us meet the global health needs of today, tomorrow, and the future. We are so proud that you've chosen to participate in First Robotics and have committed to learning new STEM skills. I look forward to hearing about each team's build progress tonight. Good luck.
At Stryker, we are driven to make healthcare better. We are driven to help people who have joint pain get back to the things they love. Oh, and we love robotics. Mako Smart Robotics is a technology that doctors use to perform hip and knee replacement surgery. It's impacted the lives of over 300,000 patients. We are driven to help you gain STEM skills with FIRST Robotics, which can one day be used to make healthcare better all over the world. Good luck to all teams in today's competition.
Wow, that's awesome to have strikers supporting our region now. All right, so up next we have team 8139. Now, the interesting thing about this team is while they may be rookies to the FRC arena, I think you'll find that they're not rookies to competition robotics as a whole. Let's hear from team 8139, Pirate Robotics out of Egg Harbor, New Jersey. All right, so Libby and I are here with Sam, Thomas, Adam, Harmon, Mr. Boyd, and Mr. Zuckel. They're advisors from Team 8139 Pirate Robotics. Hey guys, how are you guys doing tonight?
Hey Jeff, we're good. We are from Team 8139, also known as Pirate Robotics. We're from Cedar Creek High School in Egg Harbor City, New Jersey. This is our first year in FIRST Robotics, and we are thrilled to be involved with you guys. Our school was only established in 2010, and our robotics program was established my freshman year in 2016-2017. For the past 3 years, we've been involved in VRC. Today, here to represent 8139, like you said, we have Thomas and Adam, who are part of our build and design team, as well as Harmon, one of our programmers. My name is Sam. I'm a senior, and it has been incredible to watch our program grow, especially in the last year from FRC. And as a senior, it's been really great to pass on what knowledge we have learned this year to our younger generations.
Awesome. Sam, good to have you. Thank you so much for that awesome intro. So, Thomas, I believe you are the subject matter expert. Maybe you can give us a little bit of background on your team's VRC or VEX Robotics competition experience.
Well, our team has competed for 3 years in the VEX Robotics competition. I personally, as a sophomore engineer, have only competed 1 year, and we did not compete this year. We've learned a lot of styles of the robotics challenges, and we know all the common concepts such as alliances and reveal videos, competitions. So that has really helped us in moving to FRC. Because we are familiar with running a robotics team and doing the basic tasks of designing, building a robot, it has really helped us, especially the way that we've learned to work with each other, you know, having groups of several engineers to help design and come up with ideas for the robot. And it has been very good to help us in transitioning.
Cool.
Yeah, for sure. You guys are no stranger to robotics competitions in general. Adam, I know you've also done First Tech Challenge. You want to tell us a little bit about that experience as well?
Yeah, so I've been a part of an FTC team for the past 2 seasons with an outside police activities league organization. And it's really helped me with this team going through just the entire design process with breaking down the challenge, analyzing it, brainstorming what we think our robot can do, going into prototyping, coming up with different ideas, different mechanisms before we actually start building, and then into the designing throughout the whole season with coming up, analyzing the different parts that we need to buy and how that's going to fit into our robot. And specifically with me, I've learned a lot about CAD and how to use that to design parts, incorporate that with mechanisms, and really help with the overall design. But the most important is working together as a team to put all of our ideas together to create one finished product. One of the things in the transition between FTC to FRC is learning all the differences in the design challenge, dealing with more complicated, more powerful parts, and incorporating that and trying to figure out how to use it and change the design with that.
It's awesome. It seems like you guys have a a wealth of knowledge and experience for FRC rookies. That's really, really rare right now, I think. Harmon, not to be outdone, it looks like you have a little bit to talk about here in regards to your experience with the engineering magnet program. Can you talk a little bit about that?
Yeah, so for being a senior, I came into the school with the magnet program, which was the engineering part of it, and I was really like passionate about engineering when I came into the school, so that's why I chose to go into that. And one of the things about going into the engineering magnet is I get to take a class. One of the classes was engineering design and development, in which I worked on a project for a year, and yeah, I have a good deal of experience with working with real engineers and how to go about with the design process, as we have to present our information to them in a specific order. Like we have to show our design process, our problem statement, and our purpose statement, and we have to like model our time. So I have experience with like modeling the time and how to manage all the information given. And I did a good amount of coding during the magnet program as well, which gave me the experience I need, and to like back all the extra coding I did, I had computer science, which really helped me understand like what I was doing with my coding and how to go about it.
Very cool.
That's awesome.
Sounds like it definitely sounds, I gotta reiterate, Libby, it seems like they're so prepared for this. I'm really, really excited to see these guys compete for sure.
Absolutely. So Sam, like you've said, you've been with the robotics program for quite some time, and you've done VRC as well. So tell me a little bit about, from your perspective, the challenges of moving specifically to the first robotics competition for your team.
Of course. So one of our main problems was we have such a young robotics program, and with that, we don't have a lot of money invested in us. So when we found out the prices of the parts and the entry fee into FRC alone, we were a little worried because we didn't have any money in our bank account. But we were fortunate enough to search for grants, and our school was able to get a grant from NASA for us that was able to pay for some of those supplies and our entry fee into the competition. So that was really amazing. I mean, we were fortunate enough at our school that most of us are involved in an engineering magnet program, or just all of us are very passionate about our robotics program. So we're there from 2:30 to 6 o'clock every day working on it. Working on the robot was great. Our main challenge moving from VRC was that we now had all this opportunity to work with any parts such as wood, metal, motors, that you had to put a motor controller box on, which a lot of us aren't used to, but it was amazing to really gain that real life experience outside of VRC.
Very cool. Yeah, I can say, I don't have a ton of experience in VRC or FTC, but I can see a lot of new challenges that probably did arise, not just in design and build, but also in financing, right? The bigger they get, the more expensive they get, it seems like, with robots, for sure.
We see that you're extremely prepared as a team, just from our perspective. So talk to us a little bit about what your process was in that jump. It's a big challenge, but you guys did it. You got through an FRC build season, and hopefully we'll see each other on the field soon. So talk to us about that process.
On the very first day we get back from the reveal, we have to analyze the video. We have to analyze the manual to understand the game, to understand what we want our robot to do. And then the next couple days we go into brainstorming what we think our robot can be, what type of systems we could use to accomplish the challenge.
But we also use a lot of our skills as engineers with drafting. I did a lot of perspective drawings and just other drafting drawings, just on the board, on the whiteboard, in different graph papers. I did a ton to hash out what our robot would be and what direction we were pushing it in.
Cool. So Sam, maybe you could talk a little bit more about what you did to implement the engineering design process.
The engineering process, we really, or like Tom and Adam said, we identified the problem, what we wanted to accomplish, and we really came together as a group and came up with the design. We broke the robot down into parts, and we said, okay, well, out of the point system, what are the ways we can get the most points? And we came up with, we wanted a shooter robot. So if we want a shooting robot, how do we want to do that? And we would hash it out with almost a debate session in our group. So our engineering process of identifying the problem, coming up with designs, we had a lot of prototyping, a lot of testing to see, does this actually work? Is this our best option? Where should we go from here? And from there, test and retest is really our slogan. Try it again. Does this work better? And just re-identifying the problem. So we were really working to make sure that no matter what, the engineering design process wasn't forgotten.
That's fantastic. You guys, we can tell you come from an engineering background because you've got the process absolutely nailed.
So Sam and maybe Thomas and Adam, you guys can chime in here too. I want to back up a little bit here. You guys talked about this debate decision-making process. And I know in some of the previous conversations we've had, you've talked about how you try to apply a certain level of democracy to your design process and your decision-making process. Can you guys talk a little bit more in detail about that?
As a project manager on the team, it was really important to me that everyone had a say in the robot. Everyone felt that our robot was going to be the best thing it could be. So I remember in one of our first meetings, I took a packet of Post-it notes and I had everyone write their name on it and how we voted on how to decide for the robot. We drew columns on the board and everybody put their Post-it note in. And when we actually ended up having ties, every time we had a tie, we'd choose one person from each side to debate out why should we go with the shooter over a hanging robot or a spinner robot. So that was really important to us. And, debating is one of the best ways to find flaws within the systems of the robot before you start designing. So we found that helped a lot. And we learned how to compromise a lot within the design. I know there's some team members who hash it out a lot between designs and they just come together and they figure it out and work it out from there.
Cool. That can be a really great way of displaying the pros and cons. Just like you said, when it's your idea, you're passionate about a design, it's really stuck in your head. It's probably super helpful to have your teammates sort of say like, hey, yeah, yes, but also maybe this slight modification or, maybe another way is okay to sort of think through. So I think that's a really like healthy and team friendly way of doing it, but also a great way to find consensus because you're talking it out all the way through to sort of solving the end of the problem.
So you guys are super prepared. You have great experience from several different levels of robotics competition. And it sounds like you have a really, really in-depth knowledge of the engineering design process. And you're even passionate about making sure that every idea is heard on your team. So what I want to know now, or what we really want to know about now, is what you guys produced. Tell us about your robot.
So we had two main component sides of our robot. One was the shooter that Tom talked about, but the other was an elevator system that we made to intake the balls and feed them and elevate them to the shooter so they could be rapidly fed into the shooter.
Yeah, so currently what we have with our robot now is a kit, just a kitbot chassis that has just the normal sim motors. We have a intake which can intake and store 2 to 3 balls. We have a pneumatic piston that stops the balls from going into our flywheel shooter and lets us do one at a time so the flywheel can regenerate its speed and inertia after each shot. And then we have the flywheel which can shoot 10 to 15 feet accurately and 20 feet if we just blast it.
That's awesome. It's a pretty good range right there.
I like that you have that documented. It's like the options are like aiming for goal or just send it. Like I love that.
Just blast it.
So 8139 Pirate Robotics, we've been so overjoyed to have you on our first episode of FMA Plus, one of our rookies here in First Mid-Atlantic. Anything else you want to share with the robotics world before we say goodbye to you for the day?
Thank you so much for having us. We're really excited to be with you guys and really get to talk about our team with you. We really want to extend our thanks not only to you, but to Argosy for giving us a tool grant to help really start off our program, as well as NASA for giving us, support to start up and run and be able to enter FRC.
That is a wrap on 8139 for now, until we see you guys at competition, which, like Sam said, is going to happen and hopefully sooner rather than later. So thank you again, 8139 Pirate Robotics. Thank you to Sam, Thomas, Adam, Harmon, Mr. Boyd, and Mr. Zukel. You guys were incredibly knowledgeable and super awesome to talk to today. And we look forward to hearing from you again in the future. Wow, that was awesome. Experience in VRC, FTC, and now FRC. 8139, I am super excited to see you guys on the field. Hopefully sooner rather than later. Libby, who's up next?
Our final team tonight on our first episode of FMA Plus is 1807, Redbird Robotics out of Allentown, New Jersey. These guys ran into an interesting issue this year because they graduated a ton of seniors and had to do a little bit of shakeup on their design team. So let's hear about that from 1807.
All right, so here we are with Team 1807, specifically student members from 1807, Anthony, RJ, and Dan, as well as their mentor, Bob Tackett. How are you guys doing tonight?
Good, how are you?
Good. How are you?
Well, very good.
Yeah.
So guys, super excited to talk with you. 1807 is quickly rising the ranks as one of the first Mid-Atlantic perennial powerhouses. So I'm very, very grateful that you guys signed on to do a segment with FMA Plus, and super excited to hear and learn more about your team. So Dan, we talked the other night a little bit in our pre-planning meeting, and you said that you were super passionate and really excited to talk about the team structure and maybe some of the changes you guys have gone through in recent times. Do you want to kick us off with a little bit about that topic?
So yeah, pretty much from the start, preseason, we knew that this year was going to be a challenge. We had a completely new lead program team, new design team, new drive team. Pretty much our entire leadership team was just fresh, no experience. So throughout build season and preseason, we really had to do a lot of learning on the go, not only with like robot stuff, but with leadership positions and how to get things done efficiently. So with this inexperience, we did make a lot of mistakes on the way, and it took us a lot longer to do things that we want to do. But we feel like we were really proud of what we achieved, and we overcome the situations that arose, and we're just overall really happy with the season.
Wow, that's crazy. Yeah, I know that's something a lot of teams have to go through at some point, right? That's kind of the nature of FRC with the, the age limits and everything like that.
Right, with students, sort of every 4 years, you're going to turn over your student group. But it's interesting to hear how much of your team was impacted by last year's graduating class. Sounds like they were awesome, but then you guys are awesome as well in your own right. So, I mean, what was the focus for you guys in terms of those changes? What did you know was at the end point of making those structural changes for your team?
Basically, when we came into the year, it was kind of like a wake up call. When the game dropped, we're all getting ready, we're all getting hyped, and then it comes to building the robot, planning out what we want to do, and then going on to build it. It was definitely a wake up call that first week or so. We kind of came into it. We saw that it was going to be a lot harder than we kind of anticipated it to be. The seniors from last year kind of rolled through it like, a hot knife through butter. It was, they paved this path. Our robot was great. We did great at competitions. We went to Mars, we went to Worlds, like everything was good, and we didn't see, and they kind of made it look kind of easy, you know what I'm saying? But I think this year there was a wake up call, and instead of, being, slapped in the face and being like, you got to do this and kind of backing down, I think we stepped up to the plate. Overall, I think making that transition was definitely hard, but I think we couldn't have done it a better way, with the results from this year.
It says here that you guys had an interesting dynamic in regards to maybe older versus younger team members. What kind of challenges did that present in terms of like maybe not veteran or more experienced versus less experienced, but it says here you guys had a weird situation with younger people maybe being the subject matter experts on certain things on your team.
It was kind of weird, when you have a freshman designer telling a senior, build lead what to do and how to do it and stuff. The classic, seniors tell the, juniors, sophomores, freshmen what to do. It gets kind of awkward, and it's like, you don't really, you have to listen to this person. They know what they're talking about, but it's also kind of that trust thing, right? if a senior were to tell you to go do something, you're like, okay, they know what they're doing. I'm going to go do it. But when a freshman tells you to go do something, you're like, okay, like, let me just double check this. It's definitely a trust thing. But I think throughout the season, we kind of learned to trust. We learned to, have one another. And I think it worked out really well.
It really sounds like you guys nailed the idea of sort of overhauling for what you needed and trying to meet your goals. So let's talk a little bit about your process and how you enacted those changes this season. So obviously you said, right, the game dropped and it was this big scary thing because it's this brand new challenge for all of us with Infinite Recharge releasing this year at kickoff. What was your kind of robot design process and how did you guys go through that this year?
Basically, for this year, as all years, we watched the game animation and then we sat down as a team. We said what we wanted to do. And then when you have differing ideas, we split apart. One group put up a good presentation for the small bot, which was one of the main bots that we saw at competition this year. And then went for a high bot, right? So those were kind of like the two main ideas that we came into, very early was, are we going to go low and underneath the trench, be able to cycle fast? Or are we going to be a tall bot that can shoot from far away, get a bunch of balls, get a bunch of cycles in from short range? And that was a big debate among our team. We ended up going with smaller. Dan will tell you after this, we did have a young design team, right? 4 sophomores and a freshman. And now we're talking about building our robot within constraints to fit underneath the trench. It kind of seemed a bit too, ambitious. As we see, it worked out in the end. And then, what the wants and needs we wanted for the robot. We figured, we had to cut some stuff off. If we want to fit it in this space, we can't have everything, right? So we know we didn't really want a color wheel. If somebody else is going to have a color wheel, we'll draft them. It's going to be fine. But color wheel isn't essential to us right now. Obviously, we wanted to be able to shoot balls and hold 5 at a time. One of the big things was the climber. Now, with the climber, I definitely was very on top of that we needed a climber to stay competitive. I thought everybody was going to have a climber. And as we saw a competition, most teams had a climber and did climb. And so I'm happy we did that. But the climber was definitely one of those needs for the robot. Dan, do you want to add anything onto that?
So yeah, throughout the season, just like testing all of these ideas, like prototyping came in huge for us because as a young design team, we kind of had a bunch of these ideas that we didn't really know if they would work or not, or like if they're actually practical. So a lot of prototypes definitely came up clutch for us. And we have a laser cutter that was able to just quickly make parts for us and see if things would work. So that was definitely imperative to our process, just getting things done quickly, seeing if they work. If they don't, all right, let's go on to the next thing. As RJ was saying with like the low bot versus high bot, it was definitely one of those things where it was like, all right, we know we want a low bot, but can we? Like one of the toughest decisions to make was, do we think we can make this bot? And so we decided to risk it, and I think it ended up pretty well, but we definitely did have to make sacrifices based off that decision, like ditching the color wheel and not using a balancer mechanism.
Yeah, that's awesome. I think what I've come to learn, and I'm sure Libby has as well, is that you really need to think of the detail of high versus low for this game, and really decide whether or not it's worth the investment, because it definitely makes robot design and packaging like way harder, right? Because you're
exactly
crunching everything down into a tiny little pancake of a robot versus having something taller. But I appreciate that you guys had the ambition and the moxie to go for it, and obviously it paid off, so that's very cool.
So when you guys talk about your prototypes, I really kind of want to dive into this because the team that I work with has a CNC router, so you guys have a laser cutter, very similar, where you can sort of like rapidly try new things, and obviously not every team has the ability to do something like that depending on their machining resources. So I want to dive in a little bit on prototyping and on that iteration. What were some of the biggest learnings that you guys had with, and it could be any mechanism, any of the different ones that you had for the Infinite Recharge game, but what were sort of the biggest things that you figured out just by throwing it at the wall and seeing what worked, right?
Yeah, so the prototype process, I know Dan can talk more on this because he did the indexer, but I know for the shooter, we went through several rounds of development. And not only, just the one idea that we were going on, we also had like another shooter group. So we had my shooter group, and I was partners with Shane, who's another designer on the team. And then we had another shooter group, which was a 2 flywheel group. So we had 1 flywheel and they had 2. And the idea was they just put the ball in between. And then we had ours that had fingers that, changed the angle of the ball going up. But yeah, like you said, we also have a CNC router, but the CNC is great, but the laser cutter, that thing, we had, when we had an idea, Shane catted it up for me, boom, right on the laser cutter, 2 minutes later, pull it out, we're done, we're testing, we're on to the next one. I don't know about Dan, but I know that the laser cutter is definitely, instrumental in that. And going through, all the processes and not being able to be like held back from that, having the laser cutter kind of allowed us to go that extra mile.
Oh, that's awesome. Having that kind of rapid prototyping capability and being able to go to like final product that quickly is huge for sure.
Nice.
So can you guys talk a little bit about the sensor usage and maybe some of the testing concepts and code testing and stuff like that you guys implemented this year as far as the programming approach?
Yeah, so this year we had a lot of different little tricks that made our robot special. We originally were going to use time of flight sensors on our indexer to help with the balls going through. We ended up using 2 ultrasonic sensors. So we put one in the entrance of our indexer and one at the top. And the one at the bottom, so when there was a ball recognized, like we had the distance, if it was really, really small, then it would move the ball out of its view until it's gone. So basically what that would do is because we placed it in a certain spot, it would allow us to move the ball to its first slot to basically regulate that whole motion. So what would happen is as we played the game, it would make it real easier on the drivers to be able to just move that ball and not have to worry about doing that by hand. The ultrasonic at the top, when that was covered, then we would know that it's full and ready to shoot. Some big things that we also used is this was the first time that our programming team, like this current programming team, worked on PID loops for our shooter. So that was something we were working on for a while, narrowing down that shot, really making sure that we had it, so we're very consistent. And also limelight concepts. So over the beginning of the build season, we were working on calibrating our limelight to our practice target, getting it so we can be as accurate as possible and make the ease on driving as much as possible, as easy as possible. Pneumatic wise, we had to code a couple pistons to pop up our climber and 2 pancakes to pop up the rest of our climber. And then we had our collection would be able to move up and down with some pistons too. Our autonomous was something that we were working on and actually advanced over time.
All right. So let me ask you guys this. It says here that you guys had a big issue with the overall weight of the robot, which is something that a lot of us are probably very familiar with. How did you guys overcome the weight challenges this year? Because it looks like your robot serves a lot of purposes, which means a lot of mechanisms and a lot of hardware. So what'd you guys do to come around that?
So I think throughout the build season, this kind of comes with our inexperience. We figured, we're a low bot. It's all right. We don't really have to worry about weight. We don't have that much space to work with anyway. I think we'll be fine. Then we had everything kind of together and we realized, I think we're like 133. So that was kind of a shock to us. So pretty much we just went back. The climb was still in its like infancy. It wasn't in its infancy, but we were still building that. So we're like, all right, let's just pocket that. Pretty much the climb got pocketed a lot. That cut down a couple pounds. And then we just went through the rest of the robot and changed like any 1/4-inch plates. All right, it's going to 1/8. And that saved us a lot of weight. And then RJ can go into the more like build stuff from there.
Yeah. So like Dan was saying, with the robot, we're building these mechanisms through the entire build season, right? We got 6 weeks. I'm building this shooter. I'm putting my heart and soul into this shooter. And to be, however much we were, 8 pounds over, 9 pounds over, and being like, okay, we got to shave weight. RJ, you got to shave 2 pounds off that shooter, and the shooter weighs 4 pounds and all. Like, what am I supposed to do? So it's kind of like it's a team thing. It's not just okay, we got to shave weight. It's okay, everybody has to shave weight. Shooter has to shave weight. Climber has to shave weight. Chassis has to shave weight. Collection has to shave weight. And that was kind of hard for us to get our heads around. It was like, well, I'm not shaving weight. Well, I'm not shaving. But like, we kind of had to come together as a team and be like, listen, this isn't good. We need to get this done. So we all came together. We all shaved the weight off of our individual parts. Like Dan said, 1/8-inch planes instead of 1/4-inch. We had to, go to some drastic measures, right? Taking apart the chassis, trying to change things here and there. But yeah, I think we were exactly 125 when we went to competition. it was close. But yeah, I think, but that's with any team, right? You're always going to come overweight, especially, young design team. We were like, well, what's the weight? And then, week 6, we're at 133, and we were kind of sketched out, but we got it done in the end.
Yeah, I mean, it's really easy to be able to say, like, oh yeah, it's a small robot. There's no way that 125 pounds could fit in that tiny little package. It
Exactly.
absolutely can, and it will. So that's really interesting. I think a lot of teams end up at the same problem. So it's nice to hear from other teams sort of like how you overcame it and what changes you guys made. I love the idea that you're focusing on sort of like the whole team diving in together. So Team 1807, we've got Anthony, we've got RJ, we've got Dan, we've got Mr. Tackett as well. Thank you guys for being on the show. We're so glad to have you on FMA Plus, featuring our Mid-Atlantic region teams. So any other stories you guys want to tell? Any other pieces that you guys want to share before we say goodnight to you guys?
Yeah, it was definitely great to get an award for our indexer, something I designed. It was really cool to see how all this work that we put in, we were being acknowledged. Like the judges saw us do this thing and they're like, oh, this is really great. And we got an award for it and we got points for it. I think that was just one of the coolest parts of the year for me.
Yeah,
Cool.
Totally. Yeah. And I think coming together as a team, being in the stands and being able to earn, especially, an engineering award at a engineering robotics competition, that was definitely a great honor.
Awesome.
Absolutely. So something amazing to take home with you guys, not only physically as a trophy, but also as sort of a lesson learned for an awesome process overhaul. So if I want to learn more about Redbird Robotics, where do I find you guys?
So you can find our website in the link down below. It's FRC 1807 website, has our team roster and everything like that, our sponsors.
We're also on Instagram at FRC 1807.
And you can find us on Facebook, FRC 1807.
Cool. Like the consistency for sure.
That will do it for our feature on Team 1807 Redbird Robotics, and we will see you in another episode of FMA Plus. It's really cool to hear how teams want to pass on generational knowledge, and congrats on the success that you had at your competition. Thank you, Team 1807.
Cool. So let's not forget that we want as many First Mid-Atlantic teams as possible to submit and be a part of FMA Plus. I just want to say that it doesn't matter what your team has access to, what you guys have prepared, or what you have ready to go for a presentation. All we need from you guys is the inspiration and the excitement, enthusiasm to be a part of the show. So if you're interested in being featured in an FMA Plus lineup, make sure you have one of your mentors apply, and we'll get you into a pre-planning meeting and get you guys on a broadcast.
That's a wrap for this week of FMA Plus, presented by First Mid-Atlantic. We are so proud to tell team stories every week here on the First Mid-Atlantic channel, and we will see you next week for another awesome show. All right, folks, it looks like we are on with our team members from 1807. Thank you guys for making such an awesome show. We're so excited to have you guys. We hope you like the show. Please feel free to give us your feedback on Discord, on Chief Delphi. And if you want your team on FMA Plus, make sure that your lead mentor checks their email. That's where the sign-up form is. We've already got over 25 teams applied, so please make sure that you get in line because we want to tell your story. Like we said at the beginning, we want to make sure every single team gets a chance to shine this season. All right. Jeff, you should be here. You ready?
Yep.
Let's do it. I think we're really live, not just pre-recorded show live. We are really, really live.
For real.
For real. So take it away, Jeff.
Awesome. Well, what an awesome presentation we had. We had some really quality teams to kick off the FMA Plus broadcast. I'm really excited to learn more about the rest of the teams that have applied, and hopefully more of you are on the way. With that, tonight we have Anthony, Dan, RJ, and their mentor, Mr. Tackett from Team 1807 Redbird Robotics out of Allentown, New Jersey, here with us live to do some Q&A. So we're going to jump right in with some questions for you guys. Can you guys hear me okay?
Yeah, all good.
Awesome.
Okay.
Cool. So Libby, I'll go first. One of the more interesting questions that I saw in the chat is there anything you'd attribute to your increased success from 2017 to now? So people have noticed, including myself, that it seems like 2017 was like a breakout year for Redbird. So what can you attribute to that success from 2017 to now? What is your spark that has launched you guys into greatness?
I'd say definitely hard work. I know that kind of sounds cheesy at first, but once we started taking it seriously, staying late, actually, kind of putting our heads together and being like, we want to stay competitive, we want to compete, and we don't want to just, be that team that's at competitions. Oh, this is cool, and then leave. We want to stay competitive. So I think hard work. I mean, all of us in years past, 2018, 2019, and this year, we all put 100% in. And I think that that's one of the main things that our team is good at, is putting 110% all of the time. And I think that that's definitely contributed to our rising success. Is we try hard, and we go hard at it. We want to win. So I definitely say that. And our seniors from 2018 and from 2019 all poured their heart and soul into this. So I definitely say hard work kind of pushed us to the point we are today.
That's definitely
Awesome.
something I know with my own team. Something I say is, if you're in, be all in, right? And it sounds like you guys are absolutely all
Totally, yeah.
in. So one of the questions that came up from the chat today was, if you felt that your design team would struggle a little bit more with CAD, did you feel like you had to do extra prototyping to compensate for that?
So yeah, I can definitely attest that we did put a lot of more effort into our prototyping. Just because of that, it took us a lot longer to get out a robot, but in the end, it worked out pretty well.
Cool. So let me ask you guys this: did you guys build a second robot, like a twin robot or a practice bot this year?
We didn't build a practice bot this year. What we actually did was we used our 2017 robot, and Anthony can talk about that if he wants.
That's so
but we just
smart.
wired it up. Yeah, we just wired it up. Anthony, do you want to talk about that more?
Yeah, so a lot of the stuff we used so we basically took the chassis of our 2017 robot, which was very, very simple, rewired that up, and then we mounted our limelight to it. And basically any prototype that we had that we wanted to test, we would just use the electronics from that. So yeah, that was our test bot, if you will. But we didn't build like a separate one, but that worked for all our functions. It was similar drivetrain, and that's what we did.
Okay. And then let me ask you this: so you got your competition robot that's coming along in production, and you have this repurposed previous year robot, your 2019 robot that you're using for prototyping and testing and things like that. How did you guys decide who gets the competition robot and who gets the practice robot in regards to maybe driver practice versus programming and software development?
So definitely during the during the off season, our robot from this year really wasn't available for our programming and driving until way later in the season. So what we did is, in the beginning of the build season, we had like this test board almost. We didn't have like a working drive. So we would have like me and my other head programmer who would work on the 2017 chassis, and we practice driving because we were we wanted to be the drivers this year. And then we would let our freshmen, and we have one freshman, one sophomore, we would let them work on the test board. So basically let all four of those ideas kind of work together on those two things. So luckily it wasn't that much of an argument. It's like, oh, I want the 2017 bot or something like that. But we kind of just took what we had and we did our work, and it worked well.
Sure, yeah. So we have a couple of questions that sort of fall into the same vein, so I'm going to sort of mix them together and you can answer them however you like. So we got a question about, how does 1807 structure their build season in regards to deadlines? And with that, a different question was, how often does 1807 meet during the season versus during the off season? So I guess, how do you lay your calendar out, and what does that do in regards to your deadlines?
Yeah, so the way that we go about it is, so we obviously have kickoff, and then from then until the last day where we can be working, we're there all week. For the first few weeks, we had Wednesdays off just to kind of regroup and kind of stay 100%, have that day off. But once it got closer, we came in every day. I believe Tuesdays and Fridays are late nights, so we'll stay from 8. But once we got into it, we're staying till 11 o'clock. Luckily, we were able to stop so everybody would be able to get home at a reasonable hour. But as of so that's when we meet, right? We meet all the time. Weekends too, not Sundays, but Saturdays. We meet. We're there all the time. As of structuring, so we have a whiteboard in our room that's specifically dedicated to our robotics deadline. So every week, leadership comes in and we sit down and we go, okay, so what do we want? What do we want to do? What are the goals for the week? So then we go, okay, the shooter, we want to get this done. We want to get the entire prototype done. We want to start building the actual thing by Thursday, by this. And then we started, it started getting really complicated on that whiteboard because we wanted to get so much stuff done. We transferred it over to a Google Sheet. So before every meeting, our mentor, Mr. Tackett, would pull it up and we'd be like, okay, so how are we looking on, the shooter? Are we done with this? Are we done with this? Or no, are we done with this? Because we had like 4 things for the shooter. So we'd be like, yeah, Mr. Tackett, we're done with this. We're done with this. We're done with this. And it just went through the entire season. It went like that, and it worked pretty well. Does anybody want to expand on that, Anthony or Dan?
Honestly, yeah, our schedule, as RJ was saying, we started off thinking, we're going to come in here, we're going to finish our robot, couple weeks, like beginning of February, we're going to be all good. No problems. And obviously that's not what happens. So we came in, we were, again, as RJ said, we were taking the break on Wednesday, but then as the season started going, we were like, this is our crunch time. We started meeting like every day until 8 o'clock. Like, it started getting really intense, just trying to get this thing worked out. Definitely got really intense at the end because once the programmers got the robot, we started going crazy trying to test all this stuff, get all that done, getting gym time to be able to test. So yeah, from that point of view, we set our goals, and they had to be pushed back at times, but overall, like we got the job done based on our schedule, I guess.
Cool. So got another question for you guys, more of a technical analysis, and maybe some light can be shed on that in regards to your intake. So in some of the videos you guys provided of the earlier iterations of your intake, you're using a CD7 intake. And then in later iterations, we see the ThriftyBot Mecanum wheels being utilized. So you're using a Mecanum or maybe a vectored intake wheel setup. What was the reason for switching those designs? Was it to save weight? Was it to reduce complexity? What went into that decision?
So I'll take this one. I think that it was a little bit of all of what you just said, Jeff. I think it was to reduce complexity. Definitely, weight was a big issue. Like I said in the pre-recorded, we were at 125, so shaving weight wherever we could was definitely an objective. So I think it was the latter. I think it's all the things you just said: reducing complexity, shaving weight, and efficiency. In testing, we figured it worked better, so that's the reason that we went with that.
Cool.
Yeah, just to clarify what was asked in chat is more of like, was that something in your head in terms of weight? For those of us with some FRC, prior experience, that CD7, that lateral intake can be pretty heavy. So the question was really more like, did you think about it in terms of you ran into this weight problem? So thank you for addressing that. I just wanted to make sure that the question was addressed correctly. So there are a couple folks in our chat talking about sort of like the overhaul, actually a couple of your alumni, so shout out to the Redbird alumni in your chat, but talking about how part of your sort of revelation, this increase in your team has also been because of new machining and being able to do that with your business team. And so we actually had a question from Discord before the show went live that was, how do you guys find sponsors and raise funds? And I think that's probably relevant when you guys are sort of crediting your technical increases to, obviously having a new business plan, being able to buy more machines. How do you guys do that? How do you plan for and seek out sponsorships for additional funding?
Okay, so I'll try and take a swing at this. We don't have a business representative in here, so I'm going to do the best I can with the resources that I have. But
all good.
I know that in obviously we were talking about how 2017 was kind of our outbreak year. We did really good, and I think that that's when it was kind of easier, not easier, but kind of like sponsors started looking at us. They were like, wow, those two guys are good, we want them. So I think once we were able to kind of show what we could do in 2017, I think 2018 and really it kind of helped us get sponsors for 2018. And then our performance in 2018, I think helped us get sponsors for 2019. I think just overall, we also, from what I know, we contact them directly. We go through like the programs for like Johnson & Johnson. They were our main sponsor, as you guys probably saw on the slideshow. But yeah, going through, the ranks of, filling out the forms, filling out this, filling out that. And, our business team goes hard. They're there almost every day, just like the build team. They put in just as much time, just as much effort, and they get us the funds that we need to keep on building it. But yeah, I think that it's contributed to both our success and the hard work of our build team.
That's awesome. I appreciate that you guys have such admiration for your business team. I know sometimes in the realm of FRC, that's so technical heavy. The business people are sometimes the unsung heroes of the team. But I know there's one particular student on my team that will look at all the awesome things that the mechanical and the electrical and the design and technical people will produce, and she'll say, yeah, that's cute, but how are you going to pay for it? And she takes a lot of pride in that. And I think a lot of those business people out there that are raising funds and marketing their organizations should definitely take pride in that. So let's shift gears a little bit here. Let's talk about your experience at competition in regards to scouting and maybe alliance selection. So could you guys talk a little bit about how you guys scout at competition or for competition, and maybe a little bit about how you approach alliance selection?
Yeah, so our scouting is taken very seriously, as I feel it should be, because one of the biggest parts. So we have a lead scout who basically will create this form that everyone will work with, and we have two types of scouts. So we'll have a qualitative and quantitative, and we'll have a cycle, and they'll be scouting all the matches and getting an idea of, just especially in the beginning in a week one event, they're getting an idea of what these teams are all about, what's going on, drive strategies, how efficient they are, stuff like that. And then basically once all that data is collected, we'll have a big meeting Saturday night. And luckily this year we were in the position where we assumed we would be picking. So we were having a meeting, just thinking about what are possibilities, analyzing, taking all the data and just talking about it. So when it comes to our alliance selection, we're not going in blind. We actually have a pretty solid idea of what's going on. So once that happens, the qualitative scouts are kind of important because they're talking about the strategy. So they're less numbers. They're talking about what's going on with the bot per match, stuff like that. So they'll talk together, and then basically we create our ideal pick list and backups and stuff like that. And then when we go to do our picks, we base our picks based off of our playoff strategy. So for example, our strategy this year was to have one close up to the wall shooter, or us shooting from around the trench, and a shooter from a robot that would give us balls from the back to the trench. And based on that, we made our picks. So that's basically our approach coming in. And then our during the alliance selection, we just keep those values with us and do the best we can to form the best team. And then we do the best we can in the playoffs. But basically, our scouting team is very important to the functionality of our team because they're just really good at giving us data that we're not able to see while we're down on the field. So yeah, definitely a big thing.
Yeah, and I think to add on to what Anthony said, in years past, 2017, 2018, 2019, we were in a position where scouting data was important. So that learning curve on being like, okay, scouting data isn't just it's whatever, we're going to get picked by somebody, it doesn't really matter, to we need this data to stay competitive, to, really try. So I think that just like what Anthony said with, how we do it, I think that it was a learning curve the past few years, but I think we've got it down to a science.
Yeah, there's definitely been the ups and downs with our scouting. There's definitely
Totally.
been times where it's been great process, process that didn't really work out. It's definitely been fine tuned over the years.
But this competition, it was spectacular.
Definitely at its best that I've seen.
Cool. Yeah, I think that's a really unique, not unique, but it's an interesting approach, right? So instead of designing or picking, based off of pure statistics, you guys are designing your game plan. You already know how you're going to win. Now you just need people to fill the roles of that game plan. So that's a really smart, I think, really forward-thinking and efficient way of approaching elimination strategy, and then obviously using the scouting to make it happen. So awesome.
Yeah, for sure. Speaking of strategy, another chat question was your drive team all new at Hapro, and how much practice did they get before competition?
Okay, so I was one of the drivers that I actually operated the robot, and we received our robot to code pretty late in the season. So we spent it was around a week before our competition. So we took a lot of that time to start coding the robot. We had to get a lot of the code down because there's a lot of things we wanted to have in the robot that was special. So our entire drive team was completely new. There's me and the other co-programmer who were actually the driver and operator, and then we had a junior drive coach and a sophomore human player. And basically it was actually kind of magical how it all came together because we didn't get a ton of drive practice. Now, me and the co-driver, we had been driving in our life, for fun, driving the robot around, but really all of us together working as a group didn't really happen that much in the build season. So it was really cool when we came together in the actual competition and stuff started working, but it definitely took time to get down what we were going to do. So our first couple matches, or at least we could tell by the way our robot's moving, the communication and everything, the changes that we were going through, changing to the game. But yeah, it was definitely with the young drive team, it was a little scary going in. We were we're just wondering how it's going to go, but we just went in the right mindset, just came in to do our best, and then the results came from that.
Yeah, and I think it's also important to point out for our drive team, Anthony's operator, we have a driver, and then actually our drive coach is also a student. And we figured that works better. I know that I saw it in chat. We figured that works better. I mean, the communication, you can see it if you look back at some of the Blue Alliance footage. The communication between them is absolutely spectacular. I just wanted to add that point.
Very, very helpful, especially because even though we hadn't done a lot of practice before, the chemistry between us and our knowledge for knowing this type of stuff really made it happen. Because if the driver was driving up to shoot, I'd already have the hood up and revving up the wheel, and if we're about to ram into a wall, I already had that collector up. We were in sync this entire time. And definitely the choice behind the whole drive team, I thought was very, very well thought through, and really helped our performance as well.
Yeah, I mean, no matter who is on that drive team, that synergy is what is most important behind the glass. So it seems like you guys really nailed it. Jeff, do we have any other questions can we send to 1807 right now?
Yeah, it looks like we got a couple robot specific questions for you guys if you're interested. Maybe for the mechanical side or just general design specifics here. One is what are the motors in the back of your robot on the climber side for? It looks like I'm looking at a CAD rendering of your robot right now, and there's two motors that are coaxial to each other, and they're kind of down and towards the base of the climber arm. What are those used for?
So towards the base of the climber arm, I think that you're talking about the winch, and that's actually what powers our climb. So our climb flips up, and then we go over, and then the winch. It's two Neos. They're on a riveted base with a hex axle through the front, and then we have am steel running through it up to the top of the climber, and we pull it up. Fun fact, Anthony can expand more on it if he wants, but at competition, one of our first few matches, we were climbing it, and then it got overdriven on accident. So the entire winch kind of just contoured itself and came up. And it was kind of scary to watch real time. I mean, we got the climb, we stayed up, we didn't fall, surprisingly. And everything was good. And you'd think that it would be, just heart wrenching, but we got that right back in the pit. And I'll tell you, 5 minutes later, that entire thing was repaired, new AM steel. The thing was riveted back in, replaced the Neo. It was really good. But yeah, that's for the climbing mechanism.
Cool. And then it looks like we got one more technical question. This pertaining closer to the programming side of things. So the question is, how is your software structured, and how do you decide what to do and what not to do?
Okay, so we write in Java, and the structure, we actually, me and the other programming head, we weren't as familiar with command based. So, and going into this season, we didn't really have enough time to hop in. So we just use advanced skeleton, like iterative robot, just timed robot. And basically we just write it like all right in there with just the simple like teleop init and teleop periodic. And basically when we're thinking about what to do and what not to do, it usually comes through with a lot of testing. So like a lot of the big things this year was like button mapping and stuff like that. So if we're like, ew, that kind of felt gross, popping that climber up, we'll be like, all right, let's switch it or something, do a different combo. And for like, and speeds and stuff, obviously we do a lot of switches with that. But like one of the biggest things that we were testing was our autonomous. So some of the things we were having issues running our autonomous in the beginning, and we were thinking, oh, we can do a 6-ball auto, shoot 3, go to the trench, pick 3 more. But we felt that in order to ensure that like those 3 balls, the initial 3 balls would go in, we didn't want to risk taking the other ones. So decisions like that were kind of thought through, just through a whole lot of testing and thinking. But yeah, to terms to how we formatted our code, it's not the neatest thing you'd find, but it definitely gets the job done, and it's just iterative robot, just spelled out right there.
Sure. I'm very much not a coder, so insight into how code is structured is always fascinating to me. Our final question of the night, and I actually really like this, and I think we might steal this for future episodes as well, is every team has one of these. What was that aha moment for you guys during the build season? What was the moment where everything that you were trying to work on just clicked?
I can try and answer this one, at least from my experience. It was... it kind of came late for me, I think. It was week 5. We were there till like 11, and the robot was kind of being put together, and everything was kind of, like when everything kind of just falls together perfectly, like nothing's really messing up. There's hints here and there, but everything's kind of just fitting perfectly, and it's kind of getting weird. It was definitely that, the climber was on. We had to, put some, fix that a little bit, but it worked. The shooter worked. We had to fix the collection a little bit, but it worked. And I just, week 5, week 6, I was like, oh my God, like this is going to happen. Like we're going to go to competition and we're going to kill it. Our robot is exactly how we want it to be. We had, obviously, it's not perfect, but we overcame those challenges, and it's really, it was insane. It kind of all just came together like a puzzle. I know Anthony and Dan can probably say the same thing, but it was...
I know exactly what RJ's talking about. It's like that minute when like we were like waiting there, and like everyone was doing their parts, right?
Yeah.
Especially us as programmers, we're sitting there watching it come together, and we're just like, oh shoot, like we actually built like this robot, and we're about to go. Like that was definitely my aha moment when we started coding this thing, and like. Actually, one of the coolest moments is when like before we had the like string on our climber, it used to like pop up and like fly up really quickly and like look all cool, and I was just like, oh shoot, like we built this, like it was kind of sick. But that was my aha moment, kind of after everything happened and it started like becoming a reality. We were like, wow, this is kind of cool.
That's always one of my favorite moments in FRC is that aha moment, like, oh my God, the thing we made up is really happening. It's one of my favorite parts of build.
Absolutely. Yeah. I gotta say, just a high level comment for you guys in regards to your robot. You guys really figured out how to pack a lot of functionality into a tiny little envelope, and obviously it functioned very well. You guys have the stats to prove it from Hatboro. So anyways, guys, that's going to be it for our chat questions tonight. Thank you so much to Team 1807 Redbird Robotics from Allentown, New Jersey. Thank you so much, guys, for taking the time today. Don't forget, for everybody else out there who's watching, make sure to have your lead mentor check their email for information on applying and realistically getting into a planning meeting so that your team can be featured on a future lineup of a new episode of FMA Plus.
A huge thank you to our entire FMA Plus crew. These are the folks who made it happen for us. We couldn't have done it without the whole group, screening teams, interviewing teams, editing down all the team features you watched tonight, as well as moderating chat, coordinating social media, and keeping you informed. Jeff?
Yeah.
Jeff was supposed to say, we'll see you next Saturday for even more team stories and another awesome episode of FMA Plus. So we hope you guys have a great night, and we will catch you soon. Everyone have a wonderful evening, and apply for FMA Plus. We will see you soon.